Okay, so hello there. Today I want to show you one of my oldest projects to have some lights outside my porch, and that's the result here. It's looking wonderful in the night. This thing is running for more than 2 years now, and it's running perfect. It's nothing special, you may say, but there are a couple of things I want to tell you about. Okay, so inside here we have the controller, a light sensor, but what is interesting about, I have this DC to DC converter. In fact, I observed if you are using this kind of LED strip with 12 volts, because of the little resistance here, it's a lot of wasted energy. I put one of these in behind to have a proper control of the voltage here, and it's working marvelous. All this energy is coming from my solar panels, and this is my charger here. Well, it's nothing special about this charger, it's the cheapest one. I had a lot of chargers around here, MPPT and pulse width modulation and so on. So now I realize that in fact for a couple of amps like I have now, the power now, it's 25, 26 watts, 27 watts, but that's only for the Wi-Fi routers I have around the house and a couple of video cameras. I'm gonna put the lights on right now. The energy for the LEDs, for the LED strips, are coming from these batteries down here. So I have like 250 amps of AGM batteries, and these batteries are charged by a separate solar panel, like 100 watts, and I have some extra power for the daytime to make it charge a little bit, to give a little bit of boost for charging. It's not enough 100 watts. What I have to say, down here I have another solar 1 kilowatt grid, and it's working totally separated by the lights outside. So this one is running a on-grid inverter for the daytime. Okay, what I was trying to say about this small DC to DC converter, you see it here, is that I'm adjusting the current to a certain level, and now you see I have extra 10 watts, almost 11 watts more without the LED. And normally these LED strips, they are charging like 15 to 20 watts, because I have 3 LED strips and they are around 7 watt each. It's like maybe 21. Because of tweaking the voltage, I'm getting the power to half with almost the same luminosity, and this is the most important thing. The lights are almost the same, let's say maybe 10% lower than a 12 volt, but if you take it the other way, gaining like almost 10 watts per hour, it's a lot of energy, a lot of save energy. You may see I have routers and video cameras and these night lights here. In 244 hours I've been using, in 10 days, let's say, it's 6.5 kilowatts, and this is marvelous. So the schematic is very simple, I'll show you later. On the left we have the battery in connector. Up there you may see the light depending resistor, the light sensor, and of course out from the DC to DC converter. This one, it's a very standard cheap DC to DC converter. Like I told you, the most important thing is to have that threshold between power and light or luminosity. like I said, I'm gaining 10 watts at least simply by adjusting this level, this voltage level. Okay. Also, what I have to say, yes, you may see here we have a Schottky diode. Why I did that? This is from plus in, because this DC to DC converter, it's very fragile to reverse polarity. So with this diode here, I can't do any mistakes, you know. Okay, so this is a MOSFET here, and of course we have a potentiometer, a trimmer in fact, to adjust the level of the light, or exactly the level of the dark, if I may say. So how is the light resistor working? Let's see. Let's have this on 200 kilo ohms. Let's measure here, and we got 2.3 kilo ohms in this kind of light. Okay. You see, when I'm obturate. Okay, let's have 20 kilos. When I'm getting in the light, then the resistance turns to 10 kilo ohms. You see, everything is depend of the light. That's the idea of the things. So in the daytime, when the light is on this light resistor here, okay, so we have around 2 kilo ohms or something, and it's getting the gate to the ground. And slowly, when the night is coming, the resistance is going up to 10 kilos or even more, depends on the light resistor. And because we have a plus from here to the gate, the MOSFET is opening or closing, depends now. So it's closing the circuit and turns the power on for the next step. The next step is to have from drain, that's the plus and minus here, okay. And we have this DC to DC plus minus LED strips. And this is very simple to understand. So the MOSFET, it's closing the circuit, this one gets connected, and of course it have power to the LED strips. Okay, so let's see how many volts do we got here. But like I said, it's very important to tweak the output of this DC-DC converter. And for now, I found the best balance to around, okay, close it down, to around 9.76 volts, around 9.7 volts. So here is a really nice threshold, you know, between, this is a really good level between luminosity of the LED strips, LED strips, and the power consumption. Okay, so that's it for now. Thank you very much. Bye bye.